Before we move on to Chapter 3, what I wanted to do here was just look through Chapter 1 kind of page by page and maybe point out some other important things. It looks like if you look on page 4, cognitive neuroscience really started back in the 70s as a term, although people have been studying it for a long time. We talked about phrenology and galls, so that's important. You can see the pictures on page 6 looking at brain structure and behavioral functioning. But what did we say was the problem with phrenology? Not a lot of validity to things. If we keep going, page 8, as we summarize, Broca and Wernicke's area, very type reductionistic, I think we said there. Cellular architectures, cytoarchitecture. The idea is if you're good at a particular function, maybe this area will be very well developed. If not, you won't get very much going on there with the cytoarchitecture. If we keep going to page 10 and even 11, they mentioned Descartes. And Descartes was very much, what did Descartes believe? And it looks like Descartes lived in the early 1600s. Descartes, in terms of the mind-body issue, basically followed what? Dualism. Mind and body are separate, so he came up with those ideas. If we continue along and keep going here, we're not going to go into page 12. Those people are not cognitive neuroscientists. They're much more behaviorism. Penfield, the picture on page 13. Wilder Penfield was really one of the founders of cognitive neuroscience as well. He did a lot of stuff with stimulating the brain and seeing functioning there. And then if we turn to page 14, whose picture do you see on page 14 that might be important there? Chomsky. How does Chomsky relate back to our equation? What did Chomsky do to really start changing from behaviorism? He basically told Skinner that he was wrong. He said that you can't explain what? You can't explain 100% of language acquisition by what?
Conditioning.
By conditioning, by what you learn, by nurture. That there had to be something innate. Did we call that the language acquisition device last time? Did we use that term? I think we used that term. So LADS at page 14 and the language acquisition device would be part of that. And then the instruments. We can do an EEG. It's one of the instruments we can use to measure the brain. A CAT scan is often used. MRIs are often used, and especially important on page 17, functional MRIs, where you can actually give people things and see what's going on in their brain while they're processing something that they're looking at. Why would that be cognitive neuroscience? You give somebody something to look at, and then you see what's going on in their brain while they're doing it. Why would that be cognitive neuroscience? Bella, any thoughts about that?
Probably seeing which areas are more active.
Yeah, in real time, that you're basically looking at cognitive functioning. I'm seeing this letter, and here's what's going on in the brain. So very, very much measuring electrical activity. That's all the neuroscience end of it, and then looking at the cognitive activity are some of the ideas behind it. So let's continue on here. Let's see, that got us to page 19. Let's go into chapter 2 just a little bit. The structure and function of the nervous system. Basically, how do neurons work? Let's just kind of summarize that. Basically, what collects the electrical energy? What part of the neuron collects the electricity? We have 3 parts to every neuron. Not quite the axon. We got 3 parts of the neuron. The dendrites. So the dendrites collect the electricity, and where does it summate?
The cell body?
The cell body, and if you get enough electricity there, it'll generate, what is it called down the axon? an action potential. And so that's the idea of Chapter 2. We're not going to go through a lot of the details there. That's in the neuroscience class. It's pretty good for the neuroscience class. Let's see if we can get a bigger picture there, or if we're just flipping through pages. Right now I'm flipping through pages. Maybe as we get to page 42, on page 42 they start talking a lot about what particular field, 42 through 45. Actually 42 through the rest of the chapter there. What do they start going into there? What are they looking at? If you look at page 47, for example. What field of neuroscience looks at the structures in the brain? What field of neuroscience looks at the structures in the brain? We already said it once here in class. Well, it's part of cytoarchitecture, but what general field of neuroscience is it?
Physiological?
It's actually neuroanatomy. Is there a lot of, at the beginning of cognitive neuroscience, is there a lot of neuroanatomy tied to things? Yeah, phrenology, right? Here's the structure. This area is larger. That means you're better at doing this particular task. So there's a lot about that going on here. And so basically, it might be useful for you to know, we're going to do a little bit of neuroanatomy here. The hindbrain is concerned basically with primitive functioning. The hindbrain is kind of eating, drinking, sexuality, just kind of primitive functioning. The midbrain is, we don't have to go too much in the midbrain. Let's actually go to page 49 and the cerebral cortex. Actually, we have the forebrain, so I'll do hindbrain. And the forebrain is divided into two areas for you. The cerebral cortex and the limbic system. Does anybody know what the limbic system does? It's kind of illustrated on page 47. The limbic system is in charge of what happened to Phineas Gage?
Emotional responses.
Emotions. The limbic system is with the emotions. So Phineas Gage kind of ties into this because the railroad stake went through his brain and kind of changed his limbic system. So you have that, and then you have the other part of the forebrain is the cerebral cortex, the lobes, right? The occipital, temporal, parietal. You guys are familiar with this. Is there a lot of phrenology and other things going on with these structures? Yeah, very much a part of cognitive neuroscience. So you should be aware of that, because a lot of the things in class, we got on 51 the word cytoarchitectonics. Once again, you look at page 53, a lot of mind-body things. And boy, actually, a good page to look at is 55. One of the things we know in figure 1 on page 55, it's more in sensation and perception, you have the motor cortex that controls all areas of movement, and all areas of touch are also represented. So this is also the idea of kind of not so much cognitive, but more sensation and perception, areas that you perceive, areas that you move, and here's the brain structure. So there's a lot of neuroanatomy tied directly to cognitive neuroscience. The neuroanatomy represents which part of the cognitive neuroscience? Which part does that really represent? You're talking about brain structures. Is that the cognitive or is that the neuroscience?
Neuroscience.
It's the neuroscience end of things. So that is the take-home message from Chapter 2. How much fun was that? Woo-hoo. Okay, so I'll stop that recording.